Welcome, and thank you for taking the time to learn about an exciting new technology. The Electronic Warfare Digital Operator Log, or OODL, is a software solution being developed by SimVentions. At SimVentions, we develop, integrate, and transition new technology to our warfighters. SimVentions, your success is our honor.
SimVentions is proud to be a 100% employee-owned business dedicated to serving those that serve our country. We have multiple contracts supporting the Navy, Army, Marine Corps, and various joint DoD agencies. We provide support in our 6 core areas of systems engineering, software engineering, tools and innovations, cybersecurity engineering, program management, and modeling and simulation. At SimVentions, our record of success includes the experience that comes with participating in the SBIR program for over 20 years. During that time, we have been awarded approximately 25 Phase 1s, 15 Phase 2s, and 3 Phase 3 SBIRs. SimVentions has key experts in System of Systems Engineering, Model-Based Systems Engineering, CWIP Block 2, and CWIP Block 3. As the developer of the U.S. Navy's Slick 32 Tactical Simulator, or TACSIM, we believe that we are uniquely poised to deliver innovative technology in the area of electronic warfare. Headquartered in historic Fredericksburg, Virginia, we also have offices in Washington, D.C., Virginia Beach, and Dahlgren, Virginia. Our state-of-the-art facilities include over 100,000 square feet of combined office space, conference rooms, and an augmented reality lab. Our objective is to develop an automated electronic warfare event logging system for the operator display console that captures and assimilates disparate information to improve surface electronic warfare operations. The software we develop will augment the current CWIP Block 2 system by adding additional functionality. One of these additional features will be to allow the operator to filter out extraneous information. The data must be searchable by fields that are important to the operator, as well as event metadata, such as timestamp, geolocation, and operator actions. The information will be available in several useful formats, such as CSV, Excel, PDF, etc. We have plans to employ cognitive EW algorithms to aid the operator by automatically interpreting the data. Today's EW operator is bombarded with information. With every successive block upgrade to the Slick 32 comes an exponential increase in the information on the operator display. However, the graphical user interface of the Slick 32 has not been overhauled since its original development about 20 years ago. The current method of electronic warfare logging is for operators to manually record events via pen and paper. This is problematic because it requires operators to take their eyes off the screen. Recording all this data by hand is a burden on the operator, and it is likely they may fail to record important information. The sorting, filtering, and automatic interpretation of data that OODL provides will enhance situational awareness and therefore increase mission effectiveness. Our state-of-the-art user interface is being designed with input from user experience experts, software developers, as well as current and former electronic warfare operators. The user interface is being developed using a modern front-end framework called Kivy. Kivy allows us to rapidly prototype GUIs and put them in front of operators to get feedback. OODL's advanced filter capability will allow operators to build complex criteria to pinpoint data of special interest to them. Operators will be able to save and load filters for later use. The Quick Filters bar will narrow down data displayed in the intercept log with minimal effort. Our MySQL database backend is fast and efficient at retrieving large amounts of data. OODL's cognitive EW algorithms will reduce the operator's workload by recognizing patterns in the data. By utilizing Lua scripting, we can change message formats without recompiling. This will reduce maintenance costs as data models change. The technology will also seamlessly connect data with operator comments for better recall. As you can see by this graphic, we are currently in the latter half of the Phase 2 base period for this SBIR. We plan to transition this technology to a Phase 3 by the end of fiscal year 2024. This table compares the current logging to what OODL will provide. OODL replaces the current method of handwritten notes with a digital operator log. While the current emitter history log, or EHL, provides sorting, OODLE will provide that as well as a comprehensive filtering ability. What currently is up to human interpretation will soon be aided by artificial intelligence machine learning algorithms, and our technology will reduce the cognitive workload by a significant measurable percentage. We have already tested OODLE on TACSIM, which is a tactically representative environment. We would like to also perform land-based testing on the SLC-32 and ship-based testing, as well as database and tool maturation. We will need to work to identify future funding sources, and we seek to achieve Technology Readiness Level 5 by the end of the Phase 2 base period and TRL 6 by the end of the option year. Beyond that, we will continue to mature the software so that it is ready to be deployed on the target platform, the SLC-32 Victor 6 and Victor 7. Lockheed Martin is the current prime contractor for the SLC-32 Victor 6, and as such we envision partnering with them to see our technology integrated on the system. With the other related efforts that SimVentions has in the area of electronic warfare, we are able to leverage existing technical expertise to bring this innovative technology to the fleet. SimVentions is currently developing another technology called the Workload Assessment Notification and Demand Alert, or WANDA, under a separate SBIR Phase 2. WANDA will analyze the operator's workload, notify the EW supervisor when the operator becomes overloaded, and even allow them to assume some of their tasking. A current solution that SimVentions has developed, which I've already mentioned, is called TACSIM. TACSIM rehosts much of the tactical SLC-32 Victor 6 software and simulates external interfaces. It is currently in use in the embedded training lab at Corey Station and as an integration and test tool. OODLE uses it as our integration and test platform, which helps ensure our software is tactically relevant from the start.
Thank you for taking the time to listen to this Tech Talk on Electronic Warfare Digital Operator Log. Please give us a call if you are interested in OODLE or any of our other innovative technologies. Visit SimVentions.com to explore other technology solutions and engineering services that we provide.